Hi guys, we've seen in a previous video the differences between the few millimeter wave sensors, and it's time now to build our all-in-one sensor solution. For this we need some sort of project boards, a mini D1, you can also use an ESP32 board, female headers, male headers. You can also use JST cabling and connectors, USB-C adapter board, some sort of LED. In our case we'll be using a WS2812, long legs headers, as well as a I2C project adapter, which we'll see in a minute. For the sensors, I will be using for my project the SEN0395 from DFROBOT as a millimeter wave. You can also use the 1115 from Highlink, as well as the 2410B. For my sensors, I will be using the SEN0395 from DFROBOT as a millimeter wave sensor, but you can also use the LD1115 as well as the 2410 from Highlink. We will be using the BME680 as a temperature, humidity, air pressure and air quality sensor. And we will be using the BH1750 as an ambient light sensor. We also need a WS2812 LED that will change the color depending on the AQI from the BME680. So here are some examples boards. You see, you can simply use them like this without the case. We have just a project board that we mounted on top the headers for a mini D1. So the mini D1 will go something like this. We have the header for the millimeter wave sensor, and we have the header for the I2C connector. For the I2C connector you can use 4-pin headers. So these two connectors are joined together. You have the 5 volts go to the 3.3, you have the ground goes to the ground, you have the SCL connector, which is the clock pin. This goes to the pin D1 or GPIO 5 on the mini D1, and you have the SDA pin, which is the data pin, which goes to the D2 or GPIO 4 on the mini D1. So these two are joined together and to the board. And here we have the millimeter wave. You can use a 5 or 6 pin header in here, and you have the 5 volt pin, ground. On the SEN0395 we have the GPIO pin, which connects to the D0 pin, in here. If you're using a mini D1, it has to connect to this pin because this is the only pin that has a pull down resistor. The TX pin will go to the RX pin on the mini D1, which is GPIO 3, and the RX pin will go to the TX pin on the mini D1, which is GPIO 1. If you want to add the LED will connect to any of the GPIOs you want as a data. In my case, we'll go to D7. And for the power, 5 volts and ground. These are few cases that you can use for your project. All these cases allow you to add a mini D1 as well as a few sensors. You have different shapes and sizes. All these are designed for the millimeter wave. I'll place links in the description for all these cases. For my project, we will be using this case. Now this case, it's made by Edward. All thanks goes to him. And I will place a link in the description to the Thingiverse page where you can download the design. Now, let me open it up and we have a look at it. Okay, so this is the case. I made a few holes in the back for ventilation in case you want to place the sensor in here. Now this is my sensor. This is what is inside. We basically have a project board. Let me see. Okay, so we have the project board. Let's remove all the pieces. Okay, so on the project board we place the female header, and the mini D1 connects using male header. So in case we want to replace the board, this will come out and we can replace it. Then on one side we have you can use a 4-pin header for the ambient light. You have on the other side, opposite facing toward the back of the case, you can use another 4-pin header in here. This would be for the temperature humidity sensor, in case if you want to use it like this. I also added this board which have two the GST connectors, I2C connectors on one side, and you can connect the sensor using the cable like this, or if you buy the sensors which have the GST connectors on them, you can use this board as well. And you have the LED which connects 5 volts D7 and ground. So this is the sensor. On the opposite sides of the facing towards the front of the case, we have a 5 or 6 pin header you can use for the millimeter wave. So this would go something like this. This would go something like this. We have the BME680 connected with the cable, and we have the LED. If you don't want to use these GST connectors, you can just simply plug this like this, and that's it. I'm using the GST connector so I can move the sensor into the base, because if we use the sensor the opposite side like this, because of the heat from the board, the temperature would have an offset of 2 degrees. So let's connect everything. We move the temperature sensor into the base. We move the LED into the base. This goes something like this. We can now put the top cover. Now we'll put a little bit of tape on the temperature sensor. So we'll stay over the little hole we've made on the back. And we have the LED, which we can glue as well on the back of the case. Now let me connect it and see how it works. Okay, so it's on. You see the LED is green and it glows. It gives a nice green glow to the whole base. Let me turn off the lights a little bit so you can see the light. Now if you want to see the LED changing light, let's use a little bit of perfume and let's place it into the back of this sensor, and in a minute we'll start changing color as soon as the air quality index start to raise. Let me have a look. Okay, so it's already 102. It's going up. Okay, so now it's gone yellow. 141. We push it a little more. Now it's orange. $257, and now it's red. Now, if we remove the perfume, slowly you'll start, the IAQ will start dropping, and you will again start changing color from red to orange, orange to yellow, and eventually green. This will take about 5 to 10 minutes. So this is the sensor. We'll have a look now on the software side of it. So let's have a look now on the software bit of this video. Now, this is the sensor that we have in the image in here. You see the light starting to change back to yellow because the IAQ is going down slowly. Now, this sensor shows this information in here. Let's have a look first on the code. So if we go to ESPHome, let's go to this sensor. In here we have the Wi-Fi information. I use a static IP address for each of my sensors, so this way I know they always have the same IP address. This AP value is a fallout Wi-Fi in case maybe you change the router or the password for the Wi-Fi or the Wi-Fi altogether. This will create and the sensor itself will create this access point with the name from the substitutions value, the name of the sensor, and the password, whichever you decide, and this way you can reconnect it to the new Wi-Fi. I'm not logging any information from the sensor because I did notice that sometimes the board itself crashes on boot. Now on substitutions, you can give a name to the board, to the project, version number, whichever information you want to add, you add them in here. The ESPHome informations, where you declare which type of board you're using and which platform. So when you're compiling the code, the ESPHome knows how to compile it for your board. Web server, in case you want to use a web server with information, we'll see that in a minute. This is where you declare the I2C, bus, SDA and SCL ports. This is where you declare the watt. And now we start with the millimeter wave. Let's go down. Now this code in here is for the binary sensor on the millimeter wave. You can only use this if you do not want to interact with the board. You can only use this, and this will just show if someone is present or not. Also, I have added this code, which I then removed. What this basically does, when motion is detected, it will turn on the LED on the millimeter wave itself, and when motion is not detected, it will turn it off. Because I'm using these LEDs for the air quality, I do not want any other LEDs. Now this is the millimeter wave. Now we start with the BME680. The address of the BME680 by default is 77. The temperature offset, if you want to calibrate it, this is where you change the temperature offset. You can also change it later into the sensor itself. The sample rate, if you use it plugged in like me, you can use the low power, which you take a sample every 3 seconds. If you use maybe a battery for it, you can change this to ultra low power, so we'll take a sample every 5 minutes. Now the illuminance sensor by default is 23. You see on the sensor itself for the BME680 you can change the offset for the temperature. You can also change the offset for the humidity. And this is all the sensor that displays: temperature, pressure, humidity, gas resistance, IAQ, CO2 equivalence, VOC equivalent, all this information. If you do not want all of them into the Home Assistant, you can just add this internal true command, and this will hide them from Home Assistant. You do not delete them, because the code itself needs this information to generate the other values. So don't delete it, just add this internal true command, and this way you hide it from Home Assistant. Now this is the text sensor, which displays this value in here, air quality value. This does two things. It takes the value from the AIQ range, and depends on the value, it returns a message. Also changes the color on the LED. So if the IIQ range is below 50, it will turn on the LED, set the brightness to 0.35, turn on the LED on the color green with no effect on the LED, and return a value name for us. Very good. Now our IAQ is 104. Let's see what is 104. This is not this. If it's between 100 and 150, again turn on the LED. Brightness 0.35. If you want more brightness, or if you want less brightness, you change it from here. Set the LED to yellow and display the message as a little dirty. Now when it's gonna drop below 100, it will still be yellow, but it will change to good. We'll have a look at that in a minute. So this is all the codes. The last three, I think they all red, and the last one is display dangerously polluted, as well as it will start flashing the LED. Then we have in here the information about the Wi-Fi, SSID for the router, MAC address of the board, and here we declare the LED, which type of LED it is, 2812, and is using the NeoPixel bus platform, and is connected to pin D7 on the Mini D1. Okay, so this is the code, this is what is displayed. The air quality, which is the LED, this LED as well. When the LED on the sensor itself is yellow, like now, this will turn yellow. When it's green, it will turn green. Now if you want to turn this off, you can turn it off from here. You see, it turns off on the sensor itself as well. Maybe you want to turn it off during the nights. You can create an automations and turn it off and on during certain hours. Now you see it's gone below 100, and it turned green in here and in here. Then we have the LED onto the mini D1 board. You see it flashes in here, turned on, turn it off, we don't need it. The millimeter wave distance, you can set this from 0 to I think 7 meters. This is the LED from the millimeter wave. Turn it off and on. Latency is set to 2 seconds, and sensibility you have from 0 to 9. Then as sensors we have the absolute humidity, air pressure, air quality. This is the text that we've seen earlier. The VOC equivalent, CO2 equivalent, humidity, and so on. This is the millimeter wave GPIO, is detected movement, and the temperature. In case you don't need any of these sensors and maybe you want just to display the temperature, humidity, and maybe this text or whatever, you can just add internal truth to the other ones and they will be disabled. They will be hidden from Home Assistant. And here we have the diagnostic text, which port we're using, IP address, signal strength, how long it's been connected, and this is for this. You can use the same, but instead of the DFROBOT sensor you can use a 2410. I do have one, let me see which one it is, which is this one. This is basically the same, but it's using a 2410 instead of the DFROBOT millimeter wave. Now the good thing on the 2410 that you can simplify it a lot. Now let me show you, because the 2410 it has Bluetooth, you can adjust all the values from the app and then just use the GPIO on the front end. For example, on this one, this sensor uses the 2410, but I'm only using the binary sensor to detect occupancy or not. Now I do have to set the values from the app. The good thing on the 2410 that even if you reset the sensor, you will still remember the values. So this is the simple code, the very, very simple code. There is another version of this code which is a bit more complete. Let me see where. Now this is another version of the code. Is basically this one, the simple one, adding the word connections as well. You see it connects to the word, and set these values in the beginning when the sensor connects. So you can do this, you can adjust it to whatever you want. When you found the values that are best suited for you, you can just use them in here, and that's it. You don't have to, that's all the code. This is it. This and this. Nothing more. This is the simple code. Now, for the sensors themselves, you can use these Chinese ones, like these ones. Now, this is the BME680. You see, it's €5. Or you can use the better brands ones, something like the Adafruit ones. Now if you have, this is the luminance, let's see which one it is, this one. You see you have a lot of them. DFROBOT, Speed Studios, Bosch, you have a lot of them. P. Moroni. In another sensors, on two of the other sensors, I'm using this one. Now this one is 1781. The Chinese one is 550. Now I have to say that, you see, I have two sensors in here. They both faulty. One of them, after a couple of weeks, just start displaying unknown all the time. I try to reflow the little IC, the sensor itself, nothing. This one, it does work, but after a few seconds, it will the VOC will jump to like 2000, and you will just stay there. So then I have a ambient light, which it didn't work from the beginning. On this one I did reflow the IC and it's working. Then I have another one of this illuminance sensor, which it does work, but is on another address, is not on the default address. So these sensors may work or may not work, may work correctly or may not work correctly. Now for the illuminance sensor, you can use these ones. This is the Chinese versions. I have to say, they, except of the two of them, one that I had to reflow it and the other one that I have to change the address because it didn't work, the values that they produce are pretty much the same as the value from the Adafruit one, for example. Now this one, it might be a better sensor, but it's €4.23, where the Chinese one is 82 cents. For illuminance, I would use the Chinese one, and for the temperature humidity, I would use this one. I would use the Adafruit or any other one, better brands. Now, so if we look in here, we have quite a few of them. All these are really good sensors. They are a lot more expensive than the Chinese ones, but if we have a look on the sensor itself, okay, so this is just a little sensor which is on the top of the board, you see. Now this sensor by itself, it cost $549 when you buy 6,000 or more. $549. On AliExpress this sensor costs $550. So I'm not sure how they sell it that cheap, but I think this is not the original Bosch sensor. It might be a copy. It is a lot slower than the other ones. You see, it does work. This is the Chinese one. It does work. It went up, now it's going down. It does work. Now this is, let me see, this one, for example. This is one of the Adafruit ones. I have to say the values on these are more consistent. On the other room I also have an Adafruit, and the values are more or less the same as this one, where the Chinese one, sometimes it goes up, sometimes it goes down, sometimes the light turns red, sometimes it just jumps from red to green. It does the job, but I would get for the sensor itself one of these ones for the BME680. They do have a BME681 now, which is the same but adding some AI extra features. You can use one of these ones for the BME680, and you can use one of these ones for the illuminance. Now, in regards to the web server lines in ESPHome, let's go back. These lines in here, what this does is create a simple web page with all the informations collected from this sensor. Now, to visit this sensor page, all you have to do is open in a browser the IP address of the sensor. Now you can choose between a white or dark mode. You have all the information, as well as you can change the values as if you were in Home Assistant page. So let's go here into the device page in Home Assistant. Now, if I change the sensibility of the millimeter wave, it will also adjust in here. If I change the latency, 3 seconds, it will also change in here. And if I change it in here, it will also eventually, let's see, change in here. Now, on the right side, you see that is nothing but a big empty space. This space in here is reserved for the log information, because in mine I set it to none. So if we go back to the ESPHome, if we check it in here, is set to none. You can change this value, depends of what you wish, and you will have all the sensors informations, and you can see the data from each individual sensor. If you don't know the values, you can go to here, and these are the options that you can use. None, as in my case, errors, 1, info, debug, verbose, in very verbose. Now, in my case, I disable it because I noticed that sometimes you will crash the mini D1. But if you do want to enable it, you will have in here all the data from it. So this is my sensor. This is my version of the all-in-one sensor solution. If you do like it, please like and subscribe, and I'll see you in the next video.